Hello guys, in this video we will be discussing a theory part about the kurtosis or kurtosis. Anyway, you can pronounce it as kurtosis. So in the previous video of skewness, we have tried to find the skewness, that is absolute measures, and with the relative measures. But coming to the skewness, if we have to know the measures of central tendency, dispersion, as well as the skewness, we still can't find from the complete idea about the distribution, as will be clear from the following figures, in which all the three curves ABC, I will be drawing a simple graphical representation. There you will be finding it is easy. Uh, so curves ABC are symmetric about the mean M. We have the same range. In addition to these measures, we should have one more measure which called Pearson calls the converti of the frequency curve or kurtosis. So this is turned by the Carl Pearson. So if you remember the Carl Pearson formula, that is escape is called mean minus mode by standard deviation, or 3 of mean minus median by standard deviation. That is the Carl Pearson uh, formula for the skewness. So let me draw the graph and explain it in a clear way. So the graph will be as follows. So this is mean, and this is one graph, and this is one graph, and this. So this is another graph. So graph 1, graph 2, and graph 3. Okay, is it clear? So graph 3 is nothing but the leptotic curve, leptocritic curve, and this is normal curve, normal normal curve, and the last one is platycritic curve. Just try to pronounce correctly. These are the curves. We'll define the beta and gamma values based on the elliptocritic or normal or platycritic curves. So right, curve of type A. So curve of type A which is neither flat nor peak is called normal curve. This is a normal curve which is not peak and which is not flat. Normal curve or mesocritic curve. This is also called as mesocritic curve. And for such curve, and for this type of curve, type A, that is normal curve, so we will be having beta 2 value equal to 3 and gamma 2 value equal to 0. If beta 2 value equal to 3 and gamma 2 value equal to 0, then that graph is said to be of type A, that is the normal curve. Coming to curve of type B, curve of type B is nothing but the platycritic curve, So if we say that platycritic curve which is flattened than the normal curve is known as platycritic curve. So the curve which is not as one is known as platycritic curve, which is just flattened. So for that type of graphs, we will try to recognize it using the beta value. So beta 2 less than 3, that is gamma 2 less than 0. If beta 2 less than 3 and gamma 2 less than 0, we say that the graph is polycritic, the curve is polycritic curve. And coming to the curve B, the last curve of type C, it is the leptocritic curve, so we need to say the leptocritic curve which is more peak than the normal curve is called the leptocritic curve. From the normal curve, it moves to the peak of the mean. So that type of curves are known as leptocritic curve, and it will be having the beta value of beta 2 greater than 0 and gamma 2 greater than 0. If beta 2 is greater than 0 and gamma 2 greater than 0, we said the graphs are called leptocritic curve. So this is the theory part of the kurtosis, and we'll be trying to solve more problems from the next video onwards. So coming to the skewness as well as the kurtosis. Kurtosis is based upon the beta 2 and gamma 2 values, and skewness is based upon the beta 1 and beta 2 values. Sorry, beta 1 and gamma 1 values. Don't try to get confused between these two. They are simple to remember. Just have a small glance at it. This is kurtosis. Kurtosis is based on beta 2 and gamma 2, whereas the skewness is based upon the beta 1s. That's all about this video. Hope you like it. Thank you.